We talked about that there were different ways of transforming images one to another. And so I might have two images that are related by some transformation. And we talked about how if I know the transformation, I know it'll go from one image to the next. But suppose I have two images, and I'd like to figure out the transformation that takes image 1 to image 2. How would I go about doing that? Well, to do this, I need matching or corresponding points. So the way we're going to go about finding corresponding points is using something that we're going to call local features. And you'll notice it says a little 1 and a little 2 there. We're going to put some meat behind defining what we mean to be like local and what we mean to be features. By the way, some of you have taken machine learning courses and things like that, and you've seen feature vectors. That's not what we mean here. We're actually going to mean that later in the course. Here, features are going to be things that we compute about some little local spot. They're related to feature vectors, but we were here first. All right. Our goal is to find points in an image that can be found in other images. And by the way, not just found in other images, but found precisely. And what that means is, you tell me about it. I should be able to precisely determine where that point is. So just saying it's the middle of this gray panel, not so great. But if you told me it's this tip of this spear, that would be better in terms of being localized. Also, I want to reliably do the matching, right? So if I find this point, if I find a bunch of other points, I want to be really sure they say, nope, it's not this one, it's not that one, it's definitely that one, right? So this is this idea of well-matched points, all right? So why do I want to do this? Well, we talked about things like I might want to recover the fundamental matrix to recover geometry. Remember we said that if you give enough correspondences. In robotics and other computer vision things, we might want to see how a bunch of points have moved from one frame to the next. And in order to do that, I have to figure out which points were which. Or I might want to build a panorama. Now, we've talked about this in general, but here's really a beautiful example. This comes from a paper by Brown and Lowe in ICCV in 2003. Let me just play that again because it's so cool. All right. And here what they've done is they've figured out with matching points how to place each one of the pictures on top of another. In order to do that, they had to find these matching points.